Here is question number 1.328 from Irodov from fluid dynamics or hydrodynamics. In this question it is given that water flows out of a big tank along a tube bent at right angles. The inside radius of the tube is equal to r. Small r, the length of the horizontal section of the tube is equal to L. The water flow rate is Q liters per second. Find the moment of reaction forces of flowing water acting on the tube's wall relative to the point O. So here is the point O as indicated in figure. So let's solve this question. From this figure, using volume flow rate equation, volume flow rate equation, which gives us Q equal to volume flow rate equation gives us Q equal to AV1, which is again, so from this equation we can get V1 equal to Q divided by A. This is our equation number 1. Now FBD to tube, from FBD to tube. So this is the FBD of the tube, this figure. From this FBD, A, area of cross section A is equal to pi r square, because r is the radius of the tube. A equal to pi r square. Now force exerted, F1 is equal to F2, which is again equal to rho A V square. From equation 1, now from equation 1, from equation 1 implies that F1 is equal to F2, which is again equal to rho A Q divided by A whole square, or F1 is equal to F2, which is again equal to rho Q square divided by pi r square. So torque about the point O. Now torque about the point O. Torque about point O is given as tau equal to torque, tau equal to F2L minus F1 into 0. So from this figure, from this equation, we can find the torque is equal to F2L. Now as the value of F2 is equal to rho Q square divided by pi r square, by substituting the value of F2 we can find the required torque equal to rho Q square L divided by pi r square. So our required torque is, we can find the torque. So our tau is equal to rho Q square L divided by pi r square. This is our required torque. This is our required torque. Required torque.